Hello, in this video tutorial we will see how to create a model from scratch. This session is divided into three parts. It is recommended to follow the three videos in order. We will create a new area and enter geographic information into the model. We will then add WEAP elements and see how to move the labels of these elements and how to resize them. Besides, we will see how to enter information into the elements and the type of data we can use. We will be using some template files that can be used to enter data into different models. Also, we will set the general parameters. We will set the time horizon and the time step of the model. Finally, we will get the results. This exercise is similar to the one in the WEAP in 1 hour chapter of the WEAP tutorial. The elements in WEAP represent the real components of the system to be modeled. You could watch the How to WEAP First Steps video tutorial for more details. The first step is to define the elements. Then, they must be characterized by entering their associated information into WEAP. For example, if you add a demand, you need to define what type of demand is, whether it is due to population or to agricultural demand, and define amount of people or hectares. Another important information is, for example, the water use rate or losses. It is necessary to know what information is needed to characterize the WEAP elements. Besides, you can create user-defined variables. This is a powerful feature as allows you to create your models within WEAP easily. You see a list of information you may need on this slide, depending on the element that is being used. You can check on the WEAP help the information that each element could need. We are going to develop a simple model. The schematic is shown in the figure on the screen. The time horizon will be from 2000 to 2005 at a monthly time step. You should define the time step considering the availability of information and the modeling interests. The river called Main River has two water demands, a city and an agricultural area. The main river crosses the city, and the agricultural area borders the city to the south, as you can see in the figure. The multi-annual monthly average flow of the main river before the city water intake is shown in the table. In this case, we will not develop a hydrological model. The demand information is shown in the table. This column for the population demand and this column for the agricultural demand. Because it is a population, the annual activity level is 100,000 people. In the agricultural demand, it is 100,000 hectares. The annual water use rate, the population and agricultural demand requirement is 300 and 3,500 cubic meters per year. Consumption is 15% and 90%. There is a return flow. The monthly variation variables refers to the variation of the annual water use rate during the year. In this case, the population demand has no monthly variation, meaning that the requirement is the same every month of the year. The water requirement of the agricultural demand has a monthly variation. January, February, and March, no water is required, 0%. From April to September, all water is required, with 5%, 10%, 10%, 20%, 30%, and 25% respectively. October to December, 0%. The sum of the percentages should be 100%. Each demand has a water discharge point. The location is seen in the schematic. The objective of developing this model is to answer the following questions. We will answer this question by exploring the results in WEAP. Open WEAP. We are going to create a new area. You can watch the O3 WEAP New Area and GIS Information video tutorial for more details on how to create a new area and manage GIS layers in WEAP. To create a new area, you must go to Area in the menu and select Create Area. Name this area as SEI Training. Select Initially Blank and No Password Protection. Click on OK. The study area is in Austin, Texas in the USA. Draw a rectangle around the area of your project. The boundaries will appear as a green rectangle. Click on OK when you finish. We are going to add GIS data to the project. The information is in the WEAP Areas folder. Right-click on the Layer panel. Select Add Vector Layer. Go to the WEAP Areas folder, then Maps and Tutorial. Add these three layers. We need to add one by one. This is the city. Go to the Appearance tab. Change the outline color to yellow, the fill style to solid, and the fill color to yellow as well. Click on OK. Add the next one. Right-click on the Layer panel again, select Add Vector Layer, add the rivers. The color is already blue. We can leave it like this. OK. Add the last one. Right-click on the Layer panel, add Vector Layer. This layer represents the flood area of a reservoir. Change the color to blue. Outline color blue, solid fill style, and fill color also blue. OK. We added the GIS layers in WEAP that will serve as a guide, and we know the system to model. The next step is to include the elements in the model. We have three main elements: the river, the city demand, and the demand for agriculture. We are going to add each one. To create a new node, demand site, groundwater node, wastewater treatment plant, or flow requirement, click on the symbol on the node in the WEAP legend and drag it anywhere inside the schematic. In the case of the elements on which there is a stream flow, add the elements following the stream flow direction. You need to include them from upstream to downstream. We are going to add a river. To create a new river, drag the river element and drop it at the starting point of the main river to specify the head flow. Next, single-click on each intermediate point on the river. It does not have to be perfect. Then, double right-click to specify the endpoint of the river. Name it Main River. We can move the label of the elements. Right-click on the element. It does not have to be close to the label. It just needs to be on the element. Select Move Label and drag the object label to its new location. We are going to leave it here. In case the label looks very large, you may change the size of the WEAP labels. This option is available either from the General menu, Schematic, Set WEAP Node Label Size, or by right-clicking on the WEAP legend. The dialog has a slider to make the labels either larger or smaller. We can leave it like this, and we can move the label again. We are going to continue adding the demand nodes. First, the population demand. Drag and drop a demand site over the yellow area representing the city and name it Big City. We can leave the default options for now. Finish. Move the label. Add the agriculture demand. Drag again a demand site. Remember the agricultural area borders the city to the south and drop it. Name it agriculture. Finish. We have already entered the river and two demands. Now we must define how the water will be supplied to the big city and agriculture. We do this by adding a transmission link. Drag a transmission link element and drop it where the water intake is located on the river. Next, double right-click on the demand site to finish. We can leave the default options for now. Remember that in the case of the elements on which there is a stream flow, you must add the elements following the flow direction. Repeat the process to add the transmission link from the river to the agricultural demand. To complete the schematic, we are going to add a return flow from each demand. In this case, the flow direction is from the demand site to the river. Drag a return flow element and drop it on the big city demand site. Then, double-click on the river to finish. Follow the same process to add the return flow from the agriculture demand site. Be careful with the order of the withdrawal and discharge points on the river. Our model should look like this. The sequence should be withdrawal for big city, withdrawal for agriculture, return from big city, and return from agriculture. The next step is entering the data into each element. This information will allow us to understand how the water will be allocated to the demands considering the available supply. Continue with the second part of the session in the following video tutorial.